and welcome back to this Red Door Analytics online course, Survival Analysis, an Introduction to Concepts, Methods and Software. In this section of the course, we'll be talking about performing survival analysis using Stata. So there's a really important command in Stata that you should be using whenever performing a time to event analysis, and that is the SCSet command. This command is used to really easily define our timescale, our event, and our censoring events of interest. Before we delve into that further, I just wanted to remind you about our example study dataset, where we follow 686 women diagnosed with breast cancer in Germany and are interested in recurrence-free survival. This means that our event of interest is recurrence of breast cancer or death, a combination of the two. And the exposure of interest for this example is hormonal therapy. So we'll be comparing hormonal therapy to those that didn't receive any hormonal therapy. So we're going to start by reading in our data set, renaming some variables and just looking at some relevant variables in our data set. So here you can see some output from Stata. It's a combination of commands and output. The first part of the output is using the web use command, which says go into the web and select this data set BR cancer, which is the data set that we are interested in. We use the clear option just to remove any other things that may be in our saved Stata data set. And you can see if you follow along with this, that you would get the data set in your Stata. We then have some variables which aren't very easily understood what they are from the name. So I renamed the variable x1 to be age so that we can clearly see what that is. And then I use the describe command just to look at the variables ID, hormone, age, rec time, and sensrec. So ID, we can see from the variable label, is just the ID. This is a unique identifier for every observation. Every observation is a unique individual. So we don't have any repeated observations for individuals. The hormonal therapy variable is called hormone. And this is 1 when individuals have received hormonal therapy and 0 otherwise. We have an age variable, which is the age in years. This is continuous. We then have the rec time, which is the recurrence-free survival time. So this is our survival time, and this is in days. And then we have the variable sensrec, which is our indicator for our event. So this is equal to 1 when we have the event of interest, which is a combination of recurrence of breast cancer or death, and it's 0 otherwise. So we can look at what this looks like in our data set. If we use the list command, we can select the same variables and say in 1 to 10 to just select the first 10 individuals in our data set. We can see these here. So we have 10 different rows representing 10 different IDs. These are different individuals. If we look at the first individual, we can see that they did not receive hormonal therapy. They entered the study at breast cancer diagnosis at age 70. And then we followed them for 1,814 days. At the end of that period, they had a value of sensrec equal to 1, which means that they died or they had a recurrence of breast cancer. We don't differentiate between those two outcomes here. If we instead take observation number 7 down here, we see that this patient received hormonal therapy. They entered the study at breast cancer diagnosis at age 59. And we followed them for 2,172 days, at which point, after those days, they had a sensrec value of 0, meaning that they were censored at this time point. We did not observe in those days a death or recurrence of breast cancer. So let's go back to SDSet. This is the command in Stata that we use to define our survival analysis. i.e., we define the outcome of interest and the primary timescale of interest, along with other options. If you're interested in seeing all of the options, you can look at the help file yourselves. If you type help SDSet, you will get a help file pop up. And there's lots of information in there about the SDSet command. So we'll tell Stata that we would like to follow individuals from their breast cancer diagnosis until breast cancer recurrence or death. So we do that using the stset command. Here you can see we write stset, then we write rec time here. This tells us to follow from up until the time at which we have rec time, and this is the time in days. We have this option F, which stands for failure, and this is when sens rec is equal to 1. So our event of interest is when sens rec is equal to 1, when we have individuals that die or have a recurrence. We use this command scale here, this option, and tell Stata that we'd like to scale our time scale. So basically what I do is I divide everything by 365.24, which gives us our time scale in years instead of days, because it's just easier to understand. And we have this option ID, which tells Stata that we have unique observations defined by ID. This, in fact, is not necessary at this point, but we use commands later on in the course where we need to have this option here. And then we will get some output, you can see below here, from Stata, where we get some information about what we have entered already, just reiterating what we've defined in our command. And then you can see that we have some information about what we've defined. So we have 686 observations. That's not surprising. We already knew that. We have 0 exclusions. That's good. We didn't want to exclude anyone, so we would be surprised if we did at this time point. We see that we have 686 observations, which are 686 subjects. Again, that's not surprising. We see from this that we have 299 failures. So this means that we have 299 individuals who had the event. So they either died or had a recurrence of cancer during our study period. And all of the individuals in our data set contribute to 2,112 total analysis time at risk. So this is years at risk, because we've scaled our time scale here. And the output you can see here at the bottom, we can see that we follow individuals always from time 0. Time 0 here is times at breast cancer diagnosis, the study entry. And the last observed exit time is at 7.28 years. Remember, we scaled the days so that they become years now. So what is stset doing in the background? Well, it creates some variables that are used in any subsequent command used in survival analysis, which usually begin with st. So it creates these 4 variables: underscore t0, underscore t, underscore d, underscore st. And let's just look at what they are so we can describe what they are. So if we again list the first 10 observations in our data set, I'm listing exactly the same variables I had before, except now I've added these 4 separate variables. So the underscore st variable, which is presented here, represents whether or not these individuals should be included in any subsequent survival analysis. Now, here we saw that we had no exclusions from our analysis data set, so every observation should be included in our analysis. Underscore D represents the event indicator of interest. So what you should see is that this is the same as the variable sensrec, which is true all the way down our observations. Now, we'll go straight to the last variable here because it makes most sense. Underscore T0 is our time of entry. So over here, everyone, this is 0 for everyone because we follow everyone from time 0 at time at cancer diagnosis. We may look at different timescales where this could vary, but for this example, we follow everyone from time since their breast cancer diagnosis, which is time 0 on this timescale. And then we see that we follow individuals from the time 0 until underscore T here, which is exactly the same as the rec time, but divided by 365.24 because we converted days into years. So we can see that we follow the first individual from time 0 diagnosis of breast cancer until 4.97 years, at which point they either died or had a recurrence of cancer. So one thing we might want to do is look at the distribution of survival time, which is represented by _T, in those that have a recurrence or die, and those that do not, by using the indicators _D. So we can do that. If we want to summarize overall, we can use the sum command and say sum _T, and we see that the mean survival time is 3.08 for these observations. And we can see what this looks like in those that did not have any death or recurrence of cancer, and in those that did have recurrence of cancer or died. So we will cover more survival commands in Stata in the other sections of the course. This was just a quick introduction to some of the commands here. If you would like to read some more, here's some further reading. I will see you in the other sections of the course.